Welcome to Omega Virtual Learning. This is our final lesson on volume, and I'll be talking to you about volume of spheres and hemispheres. So we'll go through the formula for calculating volumes of spheres and hemisphere. We'll also go through calculating volumes of composite solids and look at exam style questions. Formula for volume of spheres given simply as 4 pi r cubed over 3. And that is a sphere. Any line from the center to the edge of a sphere is a radius. So that is a radius. That is also a radius. Even all the way diagonally will also give us a radius. So to work out the volume of these two spheres, first to check that is my radius. So r cubed now becomes 5 cubed. And now when I work it out, that will give us 104.72 cm cubed. The 12 in question B is the diameter divided by 2, so my radius will be 6. Replace r cubed with 6 cubed in the formula, and that will give us 904.78 cm cubed. Simple as that. So you just need to remember the formula. Now let's look at hemisphere. Hemisphere simply means half a sphere. So to work out the formula is just the full hemisphere formula divided by 2. And if you simplify the formula through division, when you turn division to times, the last fraction, 2 over 1, becomes 1 over half. And that simplifies as 4 pi r cubed over 6, which could be simplified further by dividing 4 and 6 by 2. That's why the formula for hemisphere is 2 pi r cubed over 3. 2 pi r cubed over 2. If you cannot remember it, just go with a sphere and always divide your answer by 2. It will also work out. So to work out the volume of these two hemispheres, our radius is 10. So r cubed becomes 10 cubed. And that gives me an answer of 2094 cm cubed. For B, 8 is diameter. Radius from diameter is 4. Replace this with 4 cubed. And that also works out as 134.04 cm cubed. So it's simple as that. Just remember the formula, replace the radius with a number, and that is done. Exam style question. We have a toy made of a hemisphere and a cone. The two toys are joined, and a hemisphere and the cone have a radius of 9, and the full toy has a height of 25 cm. We need to work out the total volume. So we start by looking at the volume of the hemisphere alone. And we quote the formula. Radius here is 9 cm, so r cubed becomes 9 cubed, and that gives us 486 pi cm cubed for the hemisphere. Before we work out the volume of the cone, we need to remember the height of the full toy is 25. And as we said, a line from the center to the edge of a sphere is the radius. So if I make a perpendicular height, that must also give me 9 cm. Knowing this as 9 cm, the remaining should be the height of the cone. So 25 minus 9 now gives me 16 as my height for the cone. So to work out the height of the cone, remember the formula? It's just pi r squared times height, all divided by 3. It's simply the volume of a cone divided by 3 from previous lesson. So this time r is 9, height is 16. Replace them in the formula. That works out to be 3,888 pi. So the total volume is 3,888 pi plus 486 pi. That gives us 4,374 pi, and that works out into a number 13,741.32. Our answers should be in the nearest whole, so approximately 13,741 cm cubed. Remember to always leave your answer with the right unit, cm cubed. Intermediate workings, you can choose not to put the units down, but the final answer must always have the units. Let's look at another exam question. We have a bowl, and a bowl is a hemisphere with a radius 6 cm. water fills 2/5 of the bowl. So this water is 2/5 of the entire hemisphere bowl. The water is poured into a hollow cone, and the depth of the water is 12 cm. Work out the radius of the surface in the cone. So we need to work out the surface of the water, the radius, because the water forms a cone shape inside the cone. We want to find the surface, the radius of it. And I'll answer in 1 decimal place. So we just begin by knowing the volume of the hemisphere bowl, 2 pi r cube over 3, and knowing the volume formula and radius as 6, replace r cube with 6 cube. So 144 pi is the volume of the hemisphere bowl. The next thing is to work out how much water do we have in the hemisphere bowl. We have a clue that says it's 2/5 of the entire hemisphere bowl. So 2/5 of 144 pi gives me 288 pi over 5. So I now know the volume of the water. Next is to work out the radius of the surface of the water in the cone. So I'm now going to work out an expression for the volume of the cone of the water inside the cone. We now know the volume of a cone is pi r squared times height over 3. So I'm just going to replace r is still going to be r because I don't know it yet, but I know the height as what? 12. So if I work that out, that simplifies as 4 pi r squared. Now what you need to remember is that I now know the volume of the water in the cone as an expression. Now looking at the question, the water inside the hemisphere is the same water inside the cone, and therefore the two should be equal. So I'm going to equate these two, 288 pi over 5 with 4 pi r squared. And then all I need to do is to solve for r. So simple equation. Pi is common to both sides, so that cancels out. Or if you divide through by pi, it will cancel out the pi. So I have 288 over 5 equals 4 r squared. I want to work out for r squared first, so I divide both sides by 4. So that's 288 over 5 times 4 r squared. Now you can write it again as 288 over 20 equals r squared. And I'm going to find square root of both sides so that I can find out r. When you find out square root on both sides, r squared becomes r, and that will give me 3.79. So r is equal to 3.79. We want our answer as 1 decimal place, so r is approximately 3.8 cm. So the surface of the water in the cone will have a radius of 3.8 centimeters. So this is how exam style question could be set, linking hemisphere to cones. That brings us to the end of our lessons on volumes. Hope you've enjoyed our lessons on volumes. Please subscribe and share with your friends, and look forward to further lessons on Geomega Virtual Learning. Thank you very much.